Hello everyone, I'm Nicole and I'll be talking to you about how penguin guano can influence the swimming behaviour and grazing rates of Antarctic krill. So we know that there's a trade-off between predators and prey. So if a prey wants to go out foraging or find a mate or do anything else in the environment, they have to do a cost-benefit analysis of then being more available for predators to be able to find them and then forage on them themselves. For krill, they tend to have this defense mechanism of finding large swarms, which is then convenient for predators to feed on them, but more beneficial for the individual. They also prey predominantly on diatoms and dinoflagellates, so there is an optimum depth where those blooms occur and an optimum time of year where those blooms occur. But this is shifting and changing, particularly with climate change, and it is now more aligned with the timing of predators, not only foraging, but also reproducing as well. So we chose penguins as our proxy predator because they forage on small groups and individual krill, and that they're capable of diving to where those optimal depths of those blooms occur as well. And we also know that it's then easier for us to focus our experiments on not only a single predator, but also on an individual that then forages on small groups themselves. So we wanted to know, do predators disrupt or suppress the foraging in krill? Does it affect their swimming behavior? And does using just a chemical stimulus such as guano elicit a response, or do they need a visual or physical presence of a predator? So we did some grazing rate experiments, some swimming behavior experiments, and in both experiments we used penguin guano as our proxy. So starting with our feeding rate experiments, we had a chlorophyll only as well as a chlorophyll and guano treatment. And the reason we used a chlorophyll only as our control was because we wanted to see active feeding rates as a baseline of what to compare to. We then had 4 replicates of each treatment as well as a control, so one that didn't have krill present, so we could look at the algal concentration over time without feeding. We then had 2 krill in each bucket, and that was to ensure that we saw a difference in the algal concentration through feeding over a long period of time as well. Here is our setup, so you can see it's pretty simple, pretty basic setup. We then sampled 50 milliliters of water at T equals 0, 9, and 22 hours. This was to give us an initial algal concentration as well as a shorter and longer term algal concentration. And then we also sized and weighed the carbon content of krill after the end of the experiment to then calculate ingestion rates as a function of that algal concentration over time. So you can see that if you look at algal concentration on the X versus ingestion rate on the Y, that for when only chlorophyll was present, which are the blue dots, we saw that as algal concentration went down, there was still active feeding and ingestion happening, whereas there wasn't very much ingestion happening even at higher algal concentrations when guano was present in the orange. This was particularly noted by the ingestion rates of the predator after 9 hours, so in that shorter term. So we can see that it decreased their ingestion rates by up to 2.5 times what it would have been had there been no guano present. We can also see that this was suppressed after 22 hours, which was much longer than we initially thought this might happen for. But if you then look at the difference between that 0 and 9 and the 9 and 22 hours, we can see the difference between 9 and 22 hours isn't actually significant. So that decrease that you see between T equals 0 and 22 hours is still initially from that first time period. Looking at the swimming behaviour experiments now, so we built a horizontal flume that we could set to 3 different flows, and we added guano at the same concentration that we used in the feeding experiments. We then added 6 to 8 krill and recorded on 2 cameras in stereo to be able to get 3-dimensional points using DLT-DV8, which looks something like this. We then calculated the turn angles and found that they were not only more frequent, but more frequently acute when the predator cue was present. So doing really short, sharp turns, more sinuous tracks try and avoid the predator cue where it's coming in from the inlet valve, but also then actively trying to find refuges as well as other krill to start to buddy up with. This obviously had an impact on their heading angles, so they were more varied and less aligned to the flow when the predator cue was also present, so much flatter, not as big a peak for where the flow was coming from. And we also saw a decrease in the swimming velocity in krill. So this may be because they were using the flow to get away from where the predator cue was coming from. It also could be that they're using the flow to push them backwards without expending energy, or it could be because they were hiding in the corners of the tank for long periods of time as well. If you then look at the velocity in relation to flow, they were actually drifting backwards at a much more significant rate than krill when guano wasn't present. So we could definitely see that there was a impact here, that the predator odor slowed the krill swimming speed. They were less aligned to the flow, and they had those more frequently acute turns to then help them avoid predator interactions as well. We also saw the suppressed feeding rates and ingestion rates over both a short and a longer time period, which was unexpected. Thank you so much for listening, and I'm happy to take any questions.